AP Calculus AB, Unit 10, Day 3 lesson. So just this first page is the lesson, and then the rest will be your assignment. So I'll make two separate videos. So we'll do the first page right now. So we're still doing volume by cross-section. So similar cross-sections. Now, most of the problems are perpendicular to the x-axis, but what if the slices were perpendicular to the y-axis? So that means they're going to be sliced sideways, and it actually changes the shape of the three-dimensional solid that you get. So let's do one together. Let R be the region in the first quadrant enclosed by the graph of y equals x squared, y equals 9, and the y-axis. Find the volume of the solid whose base is region R and whose cross-sections are perpendicular to the y-axis in our semicircles. So let's draw a picture. So first quadrant, y equals x squared is a parabola. Y-axis is here, and y equals 9. And the y-axis is this right here. So this is the base of your region. And the slices are going to be horizontal. And it's going to change the shape, the overall result. So you can imagine if they're all like this, I usually don't draw these, it's going to kind of look like that. But we just want to focus on one cross-section. So the volume this time is going to be area dependent on y. It's going to be dy. So we want the area as a function of y. And we're going to have dy slices. So the thickness is a horizontal thickness. So it's going to be half circle, and that's going to be 1/2 pi r squared dy. And we can move the pi over 2 out front. Now the radius here, this is the diameter, right? The diameter is going to equal x right minus x left. And really, x left is 0, so it's just going to be x right. So it's going to be whatever the x coordinate is, and then we're going to divide it by 2 and then square it. Now we want to get this in terms of the of y. So it's going to be pi over 8. We're going to integrate bottom to top, 0 to 9. X in terms of y, we would take the square root of both sides. X equals plus or minus the square root of y. We want the positive because it's the right half of the parabola. If we were over here in the left half, we'd use a negative, which comes up every now and then. So it's going to be the positive square root of y squared. We already brought the 2 squared on the bottom out front. And so then our final setup is going to be pi over 8, 0 to 9 of y dy. So that's our setup, and then we can use our calculator if we're allowed to, or we can do it by hand. This one's pretty easy to do by hand. It's going to be pi over 8. It's going to be y squared over 2, 0 to 9. So it's going to be pi over 8. 81 over 2 minus 0 over 2. So we're going to get 81 pi over 16 is our answer. So that's our answer. Now, just some other notes to add to this front page. Just some notes about what you need to be able to do on your graphing calculator. So on a graphing calculator, for your response, there are 4 things. There's going to be 2 questions, but there's 4 things you really need to know how to do that you can do without showing calculus work by hand. Okay, you got to still show the setups. Okay, so have to show setup. Okay, You don't have to show the actual, you don't have to write down what programs you use and this and that, but you got to show this. Like this is the setup right here, right? And then you could do all this in your calculator just by pressing some buttons, okay? Here's the major skills that you need to be able to do on your graphing calculator. You need to be able to graph a function, okay? You need to be able to solve an equation. Now, the best way to solve an equation is to set it equal to 0, graph it, and find the x-intercepts, which they also call zeros on your calculator, right? You need to be able to calculate a derivative, and there's a couple ways you can do that. My favorite is Math 8 InDerive, but you could also do it from the graph, which if you've graphed it already, okay, I guess it's option number 6, dy dx, under the second trace calc menu. And number 4, you need to be able to evaluate a definite interval. Evaluate a definite interval. And that's what we've been doing a lot lately. So something like this, 2 to the 7 of x cubed sine x dx. Like that's your setup, right? This is the setup. Okay, now you could do this. Most of the time I would do it from the home screen, Math 9, f and int. But you could also do it from the graph screen. It takes longer and you only can do one function at a time. It's option number 7, f of x dx. Option 7 under the second trace calculate menu. So these are the major things that you need to be able to do on, these are kind of like the major things that you need to know how to do from calculus. It's also the things that allow you to just show the setup and then not show all the in-between work, okay? So, you know, and again, half of the AP exam is free response. Half of the time, half of the points. There's 6 questions, free response questions. They're equal to 9 points each. So for a score of 54 points from free response, and then you get 54 points from multiple choice. Now, to get a 5, you kind of, you know, you need to get a 5 on the AP exam, you need maybe about 75 out of 108 points raw score, which means you need to get about 6 out of 9 points on each free response question, average on your free response questions, which it should seem doable. Okay. All right. So the next pages on this are a few free response questions, and that is your assignment to try on your own first. So go ahead and try it.